But we've got Nymphicus here. Nymphicus, afternoon.
Oh, you feel the new blood, huh? You want to taste it?
Well, he's new to the server. Let's welcome him and all those wonderful things. So how did you hear about the shape of the Earth argument?
Some flat Earth live streams.
Your microphone's really low.
years
Come a
ago.
bit closer. Turn yourself up a little bit.
Just some live streams many years ago.
Okay. And what have you heard?
I mean, it'd take a long time to list off everything. Probably better to say, like, there's probably not much you could tell me that I haven't heard.
Okay. Good. So you believe we're on a boat?
Yeah.
Okay. Why? What are the reasons?
Do you want more of a simplified answer or like an actual list of stuff?
Anything, and just your personal reasons. It's
I
not the
would-
same as everybody else.
I would just say my own personal like experience of science and mathematics, and like using that to back up my own fucking like curiosity, shall I say?
Mhm.
That's pretty
Okay,
much
so
why.
give us one example of what tells us or tells you you're on a ball.
One example of something that tells me we're on a ball.
Tells you that you're on a ball. Yeah. Start somewhere. Yeah.
I mean, I can easiest thing to relate to is something that somebody's told me in the past from a flat Earth perspective is, I just use the word perspective not as a meme, but literally perspective and how that works.
Your mic
I've
is
heard the
so
argument.
low.
Sounds so low. Wait, let me turn it up.
Yeah.
Your mic is fine.
Now?
Barely hear.
He's
I
audible.
hear him fine.
You're audible, but it's really quiet though. But okay, so
He's audible, Kimo. Shut up.
I'm just looking for a starting point of what the reasons you're on a ball.
We just told you one. You gonna respond to it?
I couldn't hear
my,
it.
my,
Max,
main,
to say
my,
it
my
again.
main ones from the flat Earth. Well, just the easiest one that comes to my head right now is like something that stems from the many flat Earth people that have claimed how perspective works and why the vanishing point exists and why the horizon exists versus what is the actual explanation that like the globe says, which is the vanishing point, things rising to your eye, so the land rises up and then everything's hidden behind that.
What, is
Whereas
that-
I can disprove that myself by going to the cliffs near my house and standing on the cliffs and going down the cliffs and seeing different things.
Okay. No, we're not trying to figure out if the Earth is flat. You're saying that the Earth is a ball, right?
Yeah, no, I'm saying the claims from flat earthers of how the horizon at sea level works, right? Which is land rising to your eye and then everything's hidden behind that rising land. I can disprove that myself by walking to the cliffs at my house that are a few hundred feet tall, go down to the beach, see a horizon, the ocean horizon, go up the cliffs, and I can see France.
I mean, I'm just
Destroys the argument of the flat earth for me.
okay. So that's what I'm asking. Why do you think
I
you're
just
on a
told
ball?
you.
And you're saying because you plants.
I just told you.
Because of the flat Earth argument.
Because I can disprove the flat earth argument of perspective
What
by
about
going
before the flat Earth argument? You're not sure?
Well, I had intuitions from mathematics and science that I learned as I grew up, and I experimentally verified some of them in school.
Mhm.
And I've done my own physics education, so you say, alongside my own degree.
Okay.
Which is what cemented it initially.
Tell me
Well,
about what you saw
over
when you
time.
saw what you were looking at when you saw France. You said went to the cliffs
Yeah, I was just looking out from the cliff.
and what?
If I stand on top of the cliff, I can see France. If I go down to the ocean, I can't see France.
Okay.
And that the flat earth argument is that land rises to meet the eye, so that's why the horizon exists, but it's disproved by me just standing on a cliff and
But-
going down to the sea and not seeing that France anymore.
What is that? Is that because of Earth curve? I don't quite get what you're saying. Are you saying that you couldn't see something because of the Earth's curve, or are you saying you couldn't see it because the weather was better? You went higher, it was more clearer. It was lower,
Oh, no,
the weather
well-
wasn't so clear.
No, it's the idea that on a flat plane, right, land rising to meet your eye, it's a fairly long thing to explain.
That's a pretty
Maybe you
old
just don't
argument
know it well
about the
enough.
horizon
It's hard.
rising.
It's hard to word it. On a flat Earth, the claims that have been made about land rising to meet the eye shouldn't be that affected by you going up on top of a cliff that's only like
That's
200
an
feet
old
tall.
argument. That's what I was trying to explain to you. That argument was only used when we think the horizon was physical, measurable, geometrical.
So now the horizon's a hologram?
The horizon's not measurable. It's not physical.
Why?
Because it's apparent, bro. It's a horizon. Do you know what a horizon is?
Why is it apparent? Why can't you measure
Lord
that?
have mercy.
No, but why
But
can't
you
you
just
measure
started.
it?
We can be. Go on, percent. Go on.
Okay. Would you have a horizon if you had no eyesight?
How about percent actually shuts up and Chemo, you finish with the argument instead of running away like a pussy?
I didn't run away. I'm sharing the mic.
I appreciate that, Chemo. So yeah, my
Well,
question
then
is,
continue
would you have a
talking,
horizon?
Chemo, instead of sharing it. Don't fucking
Rita,
change
you
the
can answer
subject.
this too if you want.
Don't fucking change the subject. Nobody wants to hear your bullshit.
I'm not changing the subject. He's saying that the horizon, he's asking if it's
All right,
apparent. Or is it
Chemo
acting
lost.
like it's
You
not
can go
apparent?
on with the new argument.
So, to the bro that was talking, if you didn't have eyesight, would you have a horizon?
That has nothing to do with the actual question about measurement.
It does,
because you're
he was saying
actually
that
running
the
away
horizon
from
was not apparent,
and deflecting
that's
away
an actual
from
thing.
angular
Chemo's saying it's
measurements
apparent.
versus
If you-
linear measurements.
Wait. I'll answer quickly, and hopefully this shuts it down. If you had eyesight, you couldn't measure anything visually ever.
Yeah,
That doesn't
would
make
a
just the
horizon
horizon not real. That makes
exist
all buildings
without
not real.
eyesight? Without the sense of sight, would horizons exist?
By the same argument, would Mount Everest be real if you tried to walk there with no eyesight? No, it wouldn't.
Yes, Mount Everest would still objectively exist because it's a physical, actual, material thing.
Oh, okay. I see what you're saying. Actually, you're saying mathematically the horizon's a thing, but physically it's not because you can never reach it.
I'm not saying mathematically. I'm saying metaphysically. Apparently,
Metaphysically.
it requires,
Metaphysically.
That is a buzzword. Do not use that.
it requires an observer. Is the point?
I mean, I can see what you're saying. Yes. I don't care if
Yeah,
that falls
so-
into some trap, but yeah.
It's not a trap. That's literally what the horizon is. It's the apparent location where like the sky meets the ground. That apparent intersection, that line.
No, that is not what it is.
Yes, it is, bro.
It's not where the sky meets the ground.
What is it then? What's your definition?
Well, from the globe perspective, it's just where the Earth curves off. That's it, and the vision's cut off behind that. It's not. It's not sky meeting land. It's not none of that. That's what it appears to be.
Yeah, that's what apparent fucking means, bro. Even on the globe, it's the apparent location, the apparent intersection of the ground and the sky. It's just the difference is that the ground you guys claim is curving.
And none of this is helpful in
means
actually
nothing.
addressing
This literally means
ways to
nothing.
measure it, is it?
Yeah, I'm talking about
No,
measuring.
well, I mean, this is where you intersected. I mean, you diverged with.
Yeah, but I
Chemo.
could say,
You
no.
guys said-
I could say the same
you
thing.
said
Like
it wasn't apparent.
if I put my hand in front of my eyes and I cut off half of a building, that's my hand apparently intersecting the building, right? It's the same thing. If I had no eyes, I couldn't measure that.
No, because you're confusing.
It's the same thing.
now.
Shut up. That's exactly the same
It's
thing.
not the same thing.
That
at
is
all.
the same thing.
It's
It
not
is.
the same thing.
Okay,
because
we're
you're
done with this red
confusing-
herring. Let's get
This
back
is
to ways
literally
to measure
meaningless,
the
yeah.
horizon.
You're confusing what they call the visible horizon or something like that, which isn't actually a horizon, with the true horizon.
Do you have a metric for measuring the apparent horizon that you present?
Me.
No.
It's like you're like
Percentage.
saying that if you close your eyes a little bit, then
No, I'm not
Percentage.
saying any of that. I'm asking
Percentage.
blatantly,
No, that's
do
the
you
other
have
guy
a
said.
metric
He said
for
you lift
measuring
your
the apparent
hand in front
horizon?
of your face and you're changing the horizon. You have a new
Percentage.
horizon.
It's a question that it have been asked to you. Can you answer it?
What's the question?
So, can you measure? Do you have a method to measure the horizon?
Yes.
Which one?
What do you mean, which one? There's only one horizon.
Present it to us, please. If you are so smart with the horizon, can you present it to us how you gonna measure the horizon?
All right. So the gold standard for seeing straight lines in the distance is our eyesight. So what I would do is I would take this ruler, this manufactured straight edge, and hold it at arm's length, matching the horizon from what I see. And if it perfectly lines up, then that's an accurate measurement.
With a ruler.
Yeah, the ruler isn't even necessary. That's just kind of like you could act as the control.
You didn't just
for,
say that. No, you
for
didn't
your
just
eyes.
present that as a measurement. You didn't.
Yes.
The eyes are the
Yes,
gold
he literally
standard.
said.
You're actually fucking joking, right?
I'm not. The eyes are the gold standard for seeing straight lines in the
No,
distance.
no.
Sadly,
You're
he's
actually
not
fucking with
joking.
all of us. You're fucking
That's
with
his
all of us.
actual understanding.
What?
You introduce any other lens, any equipment with a lens, and you're introducing barrel distortion.
Why is the eyeball the true like ground zero of measurement when
Because
the
it
eye
doesn't have
itself
any
distorts
distortion.
reality?
It doesn't have any distortion.
People need glasses, my man.
I said straight lines in the distance, you fool. Listen to what I'm saying. I didn't say in every aspect. I said for seeing straight lines in the distance, human eyesight is the gold standard.
What about
So
short-sighted
it counts
people?
for the distortion.
What about short-sighted people? They can't see.
And
What
straight
about
lines
you
in the
can't see
distance.
shit in the distance.
They can't see
percent.
fuck all. I'm short-sighted. I can't see straight lines in the distance.
Yes, you can. There's just a
If I wear
blurry straight
glasses, which is introducing an external lens.
Dude,
You
you
can
can
still
see
see
things
straight
in the
lines in the
distance. You
distance.
don't need the
It's
glasses.
just going to be a blurry line.
It's not a
Which
straight
in the
line then. I
future
can't measure it
can.
accurately because it's now a blurry line. It's not a crisp point.
Yeah, it's not going to be crisp ever.
So and what's
It's
your
fucking Horizon,
mathematical
bro.
what's your mathematical formula after you're gonna put the ruler in front of your eyes, and
There's no
you're gonna establish?
mathematical formula. This is empirical observation. It's dead simple.
Okay,
Even
but
you
from
half
where do you
brain.
know? From where do you know how long is in the distance? How many meters? How many miles?
You don't
how
need
many?
to know that. We're talking about side to side curvature, and you see it and you measure it as straight.
Okay, let's try to build upon that. What can we build upon that, or how would that be useful, this
To get a
metric of
measurement.
measurement that you present?
That's useful in determining the null hypothesis, the default, which is that the Earth is that the horizon is observably flat.
Null hypothesis
there
isn't
a
actually
reason
the
if you
default
just ran away
hypothesis.
That sets the tone for alternate hypotheses. The alternate hypothesis that it's curving carries a burden of proof, has to have a burden of proof, which has not been, substantiated whatsoever.
But
So
we
that's
didn't talk
why
about
The
burden of
default
proof,
is
mate.
still that the Earth is observably flat, because the horizon is observably flat still.
But when is gonna end? Because for
Once
example,
you prove the curve.
no, mate, I'm not talking about curve. We are talking about horizon right now.
Yeah.
And you
Prove
have
the-
been
prove the
applied.
curve
You
of the
have been.
globe.
Shut up, mate. You have been applied a ruler in front of your eyes, and you're gonna have a measurement. So can you explain to me from how do I know where is the end of the horizon in my perspective?
There's no end. What are you talking about?
Okay, so how long is it?
We don't know.
Whoa. Okay, but
If you
why
don't
do
know,
you
then
Talking about, we're talking about the angle.
Shut
If there's
what
any
do I-
curve side to side, you're getting
I'm not
confused.
talking about
The only
curvature. I'm not-
measurement you would have is the degrees in change of that line, and it's 0 degrees because it's a fucking flat line.
Why do I have to put the ruler in front of my eyes?
You don't have to. That's just acting as the control to confirm it for you.
So
How do you
I'm
know the
just
ruler's straight?
acting. I just acting because I'm measuring. I'm acting, but I'm ruling. I'm putting the ruler to have a measurement, but for nothing. So
It's
how?
really just it's an observation. You could use the ruler to measure it.
Okay,
What's the uncertainty in the measurement?
exactly.
What's the uncertainty?
Hmm.
Less than any other means of measuring it, of observing
Bullshit.
it. Absolutely.
That's not a
true,
number,
because,
right?
Because there
No,
is
he's
no
claiming
other
the human
lens
eye is
being
more accurate
added
than
on.
any other form of measurement.
Yes,
It's the
any
most
other lens
accurate.
that you introduce has barrel
By the
distortion.
way,
the human
No,
eye
they don't.
accounts for
That's
barrel
not the
distortion.
most
Well,
ridiculous
that's not
thing
true.
percent
Human eyes have
claim.
barrel distortion.
How would you guys measure the side-to-side curve of the horizon
We are
without
not
adding another
I'm
lens?
not measuring like that, mate.
Oh,
I'm so
no,
sorry
no,
for
no,
it.
do you
Good
see
luck.
what he's saying though? Do you see he's saying how would you measure it if you had no other form of measurement other than your eye?
No, if you didn't introduce another lens with barrel distortion. Tell me how.
How would you measure the side-to-side angle angle difference?
Yeah, the side-to-side curvature of the.
You could
Of
you
the-
could
what's
you,
it
you
called?
could
The
use you
horizon.
could use a laser on the beach and then two lasers on either end in your vision.
Let's see it. Let's
What do you
see
mean?
these lasers that first off are subject to refraction. Let's
Be
see
careful,
how
he
these are
wants 24
straight
hours.
line
Your
measurements
eye and the
of
light that comes to
side-to-side
you
curve
is
of the
refraction
horizon.
too.
Let's
The
see
light
it.
coming off of the
light reaches-
horizon is
Yo,
light
we
subject
already
to
reaches your
established
refraction.
the default. if you want to like bring that
I mean,
up as
your
a possible
default includes
measurement,
refraction
let's
as well.
do it.
So why are you trying to include refraction as a downside to mine? Your default
There's
includes
no
refraction
default
too.
position.
No,
but
it doesn't
we're
include
going-
refraction
we're
because that's how
We're
the
going off
horizon works,
his.
bro.
We're going off his gold standard of the human eye standing on the beach using a ruler. That includes
But why-
distortion and refraction
Why
as
the
well.
fuck do we have to
No, it
take
doesn't.
any internet lunatic's position as the
Because if you
default
don't now,
position?
if you don't, it
It's the
becomes a
default
circular
because
argument.
it's supported by all of our observations. Any of you, even though you guys are all in denial, if you go to the beach,
not
you look at
denial.
the water,
So,
you will
guys-
observe a flat line.
Guys, do we have
How
the
flat is
laser?
flat?
Do we have the laser experiment at hand?
Which one?
No, there's no laser experiment.
Oh no, I
Thank you.
literally,
So we
I
resort
literally
to
just
the
thought of
default
that
then.
in my eyeballs. I mean,
Well,
I thought
It's
of
the
that in my
default.
brain.
It's flat, guys.
Miss
Exactly.
Lord.
Now
Nymphicus,
you're
Lord,
learning.
which-
Nymphicus,
Miss Lord,
so
which
you
laser
understand
test
like
you
the
talking
problem
about?
that we're having here is that because the horizon is not measurable, can't use geometry to figure out where the drop should.
We are not talking about drop, Kimo. We are talking about measuring the horizon. I'm not
Just the
talking about
horizon.
where is the end, where is the... I need to know where, in your perspective, how far away is the horizon? When it's ending of the horizon in your perspective, not in my perspective.
All right,
How
but
you see it?
yeah, but we're having a conversation with Nymphicus. Where's that name
Yeah,
from?
yeah,
Nymphicus?
yeah, and this conversation have been developed and we are in this point. Yes. So why are you want to turn it back? So we are in this point. Where is the horizon ending in your perspective, in your point of view? Percentage have said to us because you put a ruler in front of your eyes and you're gonna have a measurement. So
What are you talking about, bro? The horizon never ends. It's apparent.
Okay,
All right,
so
well,
in your
then-
case, okay,
Right,
so in your case, it's a never-ending horizon.
Yes, always around you. It's never ending. Okay,
It's never ending.
Always 360 degrees around you.
365 days of the year. Hey, but
360
percentage,
days, exactly.
percentage that you do know, I don't want to get into the whole laser light and refraction thing with you, but I know you know that bends. But regardless, you know when it's said that you can measure the distance to the horizon. If you had buoys in front of, like, let's say you were in a boat in the middle of the ocean, you had buoys from you in all directions, 10 yards apart from each other. You could measure, or you could visually, see which one is the furthest one you possibly see, and easily take a measurement of the distance. So I think that's what this dude's asking us, was what dictates that limit.
I don't know why he would be asking about that when we were talking.
That was the
side
first
to side
question. No,
line.
you brought that up.
Nymphicus.
We were talking about something else
We
in
were
the first
asking
place.
about. I tried to explain to you
Oh, yeah.
apparent horizon. What do you mean? And not physical. That's why we're having the problem now. We're trying to figure out if we can measure to metric. And obviously, if we can't,
If it's not physical, Kimo, what is it?
well, this
If
is
it's
what
not
I'm trying to-
physical, it's metaphysical. It's
You can
what is
measure,
it?
yeah, but even though it's apparent, it's still physical. You can measure to the visual horizon, just the way I said. It would be a physical limitation of the distance that you can see, and you'd be able to denote that exact distance with those buoys.
It's not
What the horizon
physical.
ends up being may be an apparent visual representation, but you can physically measure where it starts
Well,
or where it occurs.
the old understanding was just that. So that's why you have a curve calculator. You measure to the horizon and see how much an object should be.
Yeah, a
right?
very good tool. A very good tool. If you have something like that,
today-
a curve calculator. If you have something like that, like a nerd calculator, it's gonna help you to say with a precise of errors what is the distance, because the Earth is not a perfect sphere. So sorry for you. It's not a perfect parabola, my friend.
Gaining because the idea that of objects being hidden is no longer a question. Height of the observer is no longer a question. Are you familiar with the black swan?
100%, and it is one of the most absurd things I've ever heard
Black
in my
swan,
life.
yeah. So what that indicates, it tells
It
us
indicates
that,
nothing.
well, it tells us that when we have obstruction,
No,
that
you think it
obstruction-
does, and you won't listen to reason as to why what you think is wrong. I know this for a fact. I've been through the Black
Dude,
Swan.
what's
countless
Kimo
times.
gonna say right now? What was he
I've
gonna
been
say?
through the
Finish
I've been through the
sentence.
Black Swan maybe a dozen.
No, finish
or more
Kimo's
times.
sentence because you're
You
so
sound
sure
ar-
you
I
answered
didn't
what
say
you're
sound
gonna say.
arrogant.
Go ahead.
No, I'm not. I don't want to get into the Black Swan because it is an absurd argument and it's just circular again and again and again.
So
it'll
you
go
have
on
no
for too
clue what
long.
you're gonna say.
You cannot talk about the black swan
I
because
can
you
tell
have
you
no
what
argument.
Kimo's gonna say.
Black swan.
Oh,
Well,
no,
He's gonna
Johnny,
say
no,
blah
Johnny.
blah blah. It's a quantum eraser's balls. Blah blah blah.
Let me show you.
We
done the
gotta
observation
we do
yourself.
gotta be better at not interrupting, even though it's chemo. Interrupting anybody because it takes away
Absolutely
from.
fine, kosher.
It's not absolutely fine. Don't
Absolutely
listen
fine.
to chemo. It's
Got
really not
spent
tolerated,
10 minutes
guys.
talking about how we should moderate. Everything's been fine. Day, morning till. So we're just trying to figure out this horizon info, and can't measure to. How are we supposed to geometry?
Yeah, but
Well,
you said we can't measure it.
You brought up the curve calculator, chemo. The curve calculator
Is this,
doesn't just give you it doesn't give you one answer.
This image, for example.
Chemo. The curve calculator doesn't give you just one answer, chemo.
What we've got
Chemo, why are you still talking?
Maybe you probably don't understand the argument, Infocus. So the idea is that.
Hold on. I gotta.
Chemo, I'm saying something to you, dude. Chemo, why are you still talking?
I'm in the middle of saying something. Hold on.
No, you aren't in the middle of saying something. You started talking when
The
I was
idea
responding to you for some reason.
Is that it's got this platform, and we have what we would have thought was physical obstruction. And then on the next day, the same height, that obstruction is no longer there.
Yeah,
The horizon
look,
has moved.
I always have the same response to this exact image that I've seen many times. We know the conditions in which light refracts and the conditions and like temperatures and all of this stuff that affect the visual aspect of seeing an image, right? We know those, which means we know when it's a good day. Sailors don't say, oh, it's a clear day for no fucking reason. They know when they're getting a true image and they know when things are being obstructed more or less. It's not just things get elevated. Sometimes they go even further down. But we know the conditions in air in which light refracts, so we can know when a good day is and a bad day is. This argument is complete bullshit. It always has been.
What is the argument? You know what the argument is?
The argument is the horizon is apparent and it moves and it can change day to day.
No, we're talking about geometry.
Well, but the base of it is that because the horizon moves day to day, you can never measure where the true horizon is because it's an apparent metaphysical thing.
Well, no, the argument is not this actual.
No, not this one picture. I'm saying as a concept, because the horizon can change apparent position in your field of view and your vision day to day, you can never measure it truly.
Yeah, he's asking you the flat earthers argument.
I'm saying it.
You can never measure geometric.
Again, I will use my same answer. We know when there are good, clear conditions because we know the properties of air and light together. We know when light gets refracted and all of these things. We know when this happens, so you can take reliable measurements on reliable days.
Well, this is it, Nymphicus. This is what I'm trying to explain or express to you. We thought we knew these things. We used to think we were on a ball, spinning, flying through space.
No.
Hold on.
I'm talking about the properties of air and light.
Calm down. We're in a rush. So we used to think we had science. We used to think there was measurable curvature. Now, you're saying to me, we know where that geometric horizon is because you can calculate variables. And I say to you, provide me a picture then of where you would say geometric horizon is.
What you know what? How about this? How about you use a bit of reason for once instead of just saying, "Oh, we need to wait for the perfect day" and all these things. How about you take the temperature on whatever day you're going out on. You make sure the weather conditions are roughly clear.
Yep.
You just take a measurement on every single day that you deem it's relatively okay to take a measurement and take an average. That's a good enough representation of the geometric horizon.
What do you mean? I don't quite follow
Take
that.
300 measurements in a year, divide your result by 300 at the end. Ta-da, you've got an average.
Look, hold on. Slow down.
Can I answer him?
Hold on, Johnny, please. I just want to try and get through. I've been interrupted numerous times.
Yeah.
But you're saying that.
No problem.
You're saying that take an average. So if you're a 6-foot observer, yeah. Where should the geometric horizon be?
I'm gonna say I might say the wrong kilometers or miles, but it's somewhere around 3 to 4.
Let's say 3 miles.
Yeah.
So then we know that if you're a 1-foot observer, it's around 1.22.
Where's the should come from, by the way, before we continue? What does should mean?
It means I don't remember the exact number for a 6-foot observer. I know it's just somewhere between 3 and 4.
Then this is
if the Earth is a ball and...
If the Earth has a radius of 3959, whatever.
Oh, it has no refraction.
Then the horizon, geometric horizon, regardless of atmosphere, should be...
But what does geometric mean?
The true ball, like on a ball, the true horizon.
We can measure from
Well,
the
be very
observer.
specific. It's a
He is.
tangent, a straight line drawn between the observer and the surface of the sphere.
I think we can infer that.
Yeah, we
I think
understand
we
that.
know
Well,
that he means that.
Chemo's not telling you that the argument. Their argument is not that you can measure the horizon done different on different days. Their argument is that the geometric horizon, which is the horizon without refraction, like Taylor.
Thank you, Kosho.
Phil just said.
Thank you.
Yeah, it's that horizon is the furthest
Thank you.
the horizon should ever be, which is not even a real argument. It's not the actual argument. It's not what anybody claims, but it's what the flaggers claims the horizon should be.
No, I'm just trying to explain so he gets the argument. He can obviously disagree and obviously come, with the review later. But the point is, if the Earth is the size you say, remember you didn't include refraction when you calculated the geometry of the size of the Earth. You just said if it's this size. So we're saying if it's this size, geometric horizon should be in this location. Now, of course, you've got this apparent horizon that fluctuates. That's fine. Moves all over the place. What we're looking for, measurable physical location, where regardless of atmosphere, that horizon will always be the same place for that observer. Nymphicus, understand what I'm asking?
Yeah.
Why is nobody
You're asking for someone to go to the moon and measure the horizon there?
No, I'm asking someone on the Earth to measure geometric. We get it all
I
the
can't.
time.
I can't remove all the interference from the Earth. That is an impossible task.
Let me ask you: when a building is half missing, why do you guys tell us how much should be missing? How are you doing that?
See, this happens every single time. Every argument boils down to you explain from the ground up how this works. I can't go from the basics of engineering and mathematics all the way up to now I know why. Now I can tell you why this much is missing. You're asking me to explain so much. I can't simplify it down because it's actually a lot to answer. This is the same thing that happens every single time. Everyone asks for a simple answer to something that actually includes quite a lot of background.
It's almost like this is a dishonest debate tactic.
Yeah, it is actually.
Chemo, he already covered it, Chemo. He said that you take a series of observations under different conditions and you utilize that for establishment of an average. And it should be actually, shut up, I'm still talking. It should be considered as a useful average in order for the determination.
This is what I'm asking.
And you blatantly ignored it. So we're going to move on from your little red herring and we're going to cover about what do you have to build as a metric of actual measurement. And you can even incorporate what percentage over there used, percentage used of the side-to-side measurement.
No, that's not what I'm asking.
I know, because you're trying to deflect to your little nonsense red herring, and we're not going to do that anymore. So go ahead and let's provide what you have for a useful metric of measurement.
First point was, why does he think he's on a globe? And he said it because he can go higher and see further. And I'm saying, well, what difference? He's including height now. He's saying if I go higher...
Oh, no, wait, just so you know, the distance between me and France at those cliffs is barely too far to count as beyond the horizon.
No, but I'm saying that you included height. That I went higher.
Yeah, of course I did.
You started calculating, I'm higher, then I can see this much. If I go lower, I can see this much. Why?
No. I didn't say this much or this much. I said I can see literally none of France, or I can see France.
See all of it.
Like I can see the beach upwards to what the land of France covers, but I can't see all of. No, I can't see all of France. Why?
No, you can see to the bottom, to the beach.
I can see the beach of France.
Welcome to flat Earth. But
no, but when I stand on the ocean, when I stand down at sea level, I cannot, which quite literally disproves the argument of perspective rising or any geometric apparent horizon arguments.
That's my point now. You said you're going down lower, and now you can't see France.
Mm-hmm.
So how do you know it's not just a wave or tide?
Okay, this boils back down to I know when a good day and a clear day is, because if I stand on the cliffs, I can see all of the waves. And I know there aren't any massive waves going by, because it's the fucking English Channel.
No, I know that. I'm just saying, if you had a measurement, you would know more accurately.
Well, you're just going in circles here. You're just going in circles. And this is a red herring, like as everyone's been saying. I know this is red herring. I've been through this argument countless times. I'm only new to this Discord. I'm not new to everything else, by the way.
Yes, but all we're establishing it is, can we measure to the geometric horizon? You're saying yes, we take averages. And I'm saying averages of what? If I'm a 1 foot observer, when you say averages, what are we looking for?
You're
average
taking
of what?
Again, this is with the assumption that you're taking measurements on relatively clear days, relatively reliable measurements.
No. Over the 365 days.
Yeah, but it's based on this assumption that we know the properties of air, we know how light refracts, because I don't think anyone's going to try and say that isn't a thing, because that would be insane, right? We know when a good clear day is for taking measurements. We know.
But I'm asking you measurements of what? Averages of what?
Yeah, I'm getting to that. I'm just making sure that the base is laid there so you can't...
Yeah, you know all about these variables. Now I'm asking you, what is the average of what? You're 1 foot observer.
Of the observer's apparent horizon.
No, but again, how do you know the size of the Earth? You're saying average of what? Where should what be?
You don't need to know the size of the Earth to measure the distance to the horizon. That is absurd.
Okay, so, like you said, 365 days.
I haven't said you need to know that.
Okay, so over the year, what is the average?
I don't fucking know. It's a hypothetical. Why would I know the measurement?
So we don't know where that geometric horizon is.
No, because I haven't spent a year of my life measuring the average of a geometric horizon based throughout all conditions of another person.
That's a start. So
it's not a start because it's not even like a crux of my argument.
Okay,
it's just an obvious thing.
Fair enough. You haven't done it. I haven't done it. Do you know anyone who has done it?
No.
No, so we don't know anyone who's done it.
No, I don't know anybody in my life that's done it, but I'm sure someone has.
Well, do we know that? That's what we're going to try and find out now. Personally, I don't know anyone who's done it. You don't know anyone who's done it.
I'm sure we can find someone that has.
Well, let's try and find someone then. Who has done these measurements of the curvature?
I'm going to say look it up, and that's only because I need to go to work.
Look it up where? Where do we look it up?
The internet. You can look it up through scientific journals, scientific not encyclopedias, but journals and
now we're getting somewhere.
But is that a smart suggestion? Because Kimo was a flat earther.
I'm saying that it's never been done. You're saying that it has been done.
Everybody here can look it up.
You're saying it has been done. That's your positive claim. Let's have a look.
No, I didn't say it has been done. I said I'm sure we probably could find someone who's done it. It's a very high likelihood that someone's taken an average measurement of the horizon.
Well, let's take a look then. Find it. It should be easy then.
Again,
well, it would be easy.
I would do it right now, but I have to go to work. Like unironically, but I'll be back later.
You're right. It is easy, Chemo. As was covered about 2.5 months ago, just take your butt down to the local library and ask them to help you.
Yeah, nobody's done this.
That's correct. You have not done this.
You heard that I can't find it. He doesn't know anybody. I don't know anybody.
Nobody done it, Kimo. Nobody go into the library. Nobody have it internet connection. Nobody. So
because that's where we are as you go to work. Is that you don't know anybody. I don't know anybody. You haven't done it. I haven't done it. So there's no reason to think that anybody.
No, Kimo, it's not a conclusion. Right? He was saying to you.
Step 1.
Look it up.
When you come back, and get on step 2, which is Earth turn. So while you're at work, Google how you know the Earth is spinning and stuff, and then we'll have a look at step 2. Yeah.
No. You won't, because you haven't done it already. You have no inclination to actually do it, because you want to stay here and just do your circular nonsense.
Well,
and you still haven't answered the question about what you have as an actual useful metric to measure the horizon.
I just wanted to establish with our friend here, Nymphicus, how does he know we're on a ball? How does he know he's on the globe? And so far...
Chemo, just stop it. Now you're just going to go into monologue and actually saying he said stuff he didn't. You've done this pattern before.
He knows I haven't made measurements of curvature, and he knows I don't know anyone who's made measurements of curvature. So, right now we're under the belief, have faith that somebody somewhere has done this miracle. Right, Nymphicus?
And I've done it, and you, for some reason, feel to be the adjudicator of telling me I did it wrong. But you didn't have any technical issue with it. You just didn't like it.
How do you establish a horizontal plane?
The same way everybody does, by establishing the vertical, the plumb bob, which is exactly equivalent of horizontal. There you go. Done.
Yeah, how can it deviate without a force?
Because your plumb bob hangs and my plumb bob hangs for the exact same reason. You can assign...
Answer my question. How can it deviate without force?
Who's deviating? Nobody's deviating. Vertical is radial.
The plumb bob. How can the plumb bob show deviation without a force?
You either establish how this deviation of force thing that you want to stipulate is a consideration for an observation. How is it going to actually factor in and be something that actually is important with just making the observation?
What is that force?
It doesn't matter. Yeah.
You can't be and that nobody's measured it. I show you the measurements, and you just hand wave it because you don't like the way it was done, but you have no technical background. You had no technical tear-up. You just said, oh, you didn't establish horizontal plane. Yet I did establish vertical, and you and everybody else, yeah, but horizontal is perpendicular to vertical. So once you produce vertical, you have produced horizontal at the same time because they are rigidly fixed to be 90 degrees apart. So I did establish the vertical, which does give me the horizontal, did it in multiple locations, 11 miles apart, measured the angles, did not get anywhere near flat by a fucking long shot. So now you're telling me it's never been measured, and you don't like my measurement when I do measure it. And I'm not cut and pasting, I'm not a Google searching. I did it with Jesse. We went out there with our analog equipment, pencil and papers, did the old-fashioned way, just like they did for Mount Everest, and got very, very conclusive results on the fact that plumb bobs do not hang parallel by measurement.
Yeah, well, like I said, you didn't establish your... Who was that?
Yeah, I was just gonna...
Go for it.
I just wanted to see if I heard him right. You and Jesse did it the old-fashioned way with your pencils?
Analog equipment and recording data by pencil and paper, nothing computer-driven. Analog theodolites. My particular theodolite's like 45 years old. His is like 30 years old. Yeah, and then the data was recorded by pencil and paper. And yeah, that's how we did it. And the vertical angles from A to B and B to A are dissimilar by amounts a magnitude greater than instrument error. So yeah, that's what we did. And Jesse and Chemo just doesn't like it because vertical and horizontal are 90 degrees. So once you establish one, you get the other. And he says, "Oh, I didn't have a horizontal plane. No, I had vertical." Okay, that's the same thing.
Yeah, but multiple horizontal planes, right?
Well, a horizontal plane only exists at the point above at the point of the instrument.
Well, I mean, unfortunately, Larry, because of how optics work and how you mistakenly think distance objects as deviating, we need a more practical demonstration. So, you know, we almost had to force the line, which I think they thought it would have cost £100,000, ended up costing £400,000, so they scrapped it. So that's the kind of measurements that are needed. Done. Not something that's easy, Larry. You can't just establish your horizontal looking through a scope.
I think call somebody because that's how they did Mount Everest and they got the right answer. So you can just fuck off and die with that one because measurements have been verified that they do work. We've looked into it. I mean, optics have been around for about 500 fucking years. Yeah, they looked into it. What do you think? You're just like late to the and you get to say, oh, they've been wrong for the past 400 years. What's wrong with you?
So I've posted an image in the chat for you. That's how you would go about forcing or establishing your horizontal. See? Now, if you could drop like that along that line, along the tangent, then obviously we're on curvature. But because the horizon is not physical.
Well, we're in luck because that's what they did at Lego. So that's been done. So you can save your money because it's been done and verified just exactly the way you're asking for it. So
Lego.
It's making time to introduce me to the game. Let me come into the game so I can answer the question.
The Lego vacuum tubes are exactly what you just said. Been done.
Curvature.
Just
Lego.
Can I come into the game so I can put out things?
Gee whiz, Chemo. Looking at your picture here and what he describes, he actually did the first two sections.
If you're talking about Lego and so on and so on, there's so many things that we can point out that is
Tell them that they're full of shit.
It's not fitting to the reality. But that's the reality with LIGO is that it's the old experiment of the ether.
You gotta put it on thick.
Dude, you're wasted again. Chill.
And the light, how light travels and meets in the circle. So there we have it. And we have.
That has nothing to do with the construction of LIGO and the curvature that it shows. Thanks, though. Thanks for playing, Johnny.
Yeah.
But thanks for playing.
But you know, if you put something on that straight line, one second.
It's part of it.
If you put something round on that straight line, it's gonna spin back to the beginning of the line. You know that, Kimo?
But surely, if it had curvature, then you could measure it.
Kimo, where do you run it? You have posted a picture, and I want to ask you something about that picture.
Kimo said everything about it, but you.
All right, let's go again,
everything
Jack.
Against him. I have explanations. So why not talk to me then? Because you are afraid to talk to me because I know what it's about. And you are afraid to talk to me because you're
fucking drunk and you don't have not even a sense to understand what you're saying.
Oh really? Oh really?
Yes.
Do you know how the experiment of Morris and how the ether and the LIGO is the same thing?
Enlighten me, please. Tell me how it was done.
Okay, it's the same thing. It's about how light goes in a circle. If two lights goes in the same time, and
hey Johnny, I don't mean to. I just want to cut this short because I don't think we're talking about light. We're talking about the construction of the LIGO facility and the measurement that Larry was talking about, which was measuring the straightness of LIGO. So we're not talking about the actual purpose of LIGO.
You're right, but LIGO is about light. It is about light. So
basically, the waves. And LIGO experiment, they had a similar setup, and the experiment was so sensitive. If you were working on your car outside of the building, they would feel the vibrations and it would wipe out the light pattern fringes. It looks like we're connected by a sea of ether that is giving us waves everywhere, and is quite.
Lemon, we're talking about
in the sea.
Talking about the construction of the vacuum tube.
A glorified etherometer, effectively.
We're talking about the construction of the vacuum tube, not what goes on, not with the science of the instrument. We're just talking about the vacuum tube being built straight and its elevations of the vacuum tube not being constant, which is exactly the Brian Mullins forced the line test that Kimo thinks needs to be built. And I said, well, fortunately, it's been built and it's 4 kilometers long. And it's exactly what Kimo asked. Not anything to do with anything to do with
Okay.
Your mic is absolute crap, and you have to relax talking to the microphone or something because it was terrible.
No, the fourth line thing at last, trying to prove that it's a globe. Okay. The thing is, they were building on marshy, swampy land, and as in general, the land slopes.
Hey, where are you? Lemonbird. What's happening?
Cut out there, Lemon.
Just saying.
You cut out right at the marshy land.
You cut off.
See, what happened was we went to measure the slope or the curvature of the earth, and it wasn't there.
No globe. Basically, you just have marshy, hilly land sloping gently down toward the sea like continents do. Continents be that, they slope.
You're cutting out again.
So continents slope gently down toward the sea. No ball. No ball at all.
What?
You were cutting out Lemon Bird. We didn't hear what you said before, so we didn't hear. Can you?
Hey, Lemon, you forgot to add amen at the end of that.
Okay. We didn't hear it.
Yeah, if you take a look at the elevation. No ball at all.
Let him say it again.
I was just saying, no ball, just land sloping gently toward the sea, no ball at all.
What about the land that slopes up towards the sea?
In general, land slopes gently down toward the sea, towards sea level. In general.
Yeah, in general, but what about the land that slopes up to the sea? Does that conform to your incorrect notion of no ball?
I need to go with a real example to go with your hypothetical. If I had to wager what it was, land left over from the flood, when the land was nice and squishy and spongy before it set to the rock formations that we see today. So you could have a slope upward toward the sea potentially.
Cliffs of Dover, Cabo San Lucas. Yeah, we heard you the first 3 times.
With cliffs. Oh, y'all are talking about cliffs. Oh, well, I'd have to see if all ocean, all sea lines are like that, or if that's the exception. Also, let's not forget about the Antarctic ice wall, which is a big sheer drop. Let's not forget about that either.
Wonderful. I like listening to you, Lemmerport. You are like you are a fucking genius.
Do you want to address the sections of Antarctica that are not this ice wall?
Your hypothetical. I need to see things that actual go with your hypothetical. Otherwise, I dismiss it.
It's not a hypothetical. It's an observation. Multiple observations.
Okay, I believe you.
Lemon Bird.
I believe you.
No, don't believe me. Don't believe me. Go look it up for yourself, Lemon.
Hey, Lemon Bird, you were called a genius. How does it feel?
Well, I just try to learn from different people. I think the thing is, I'm a generalist who takes different perspectives and try to collate them together into a general schema based off of some foundational truth. It's making me less myopic and closed-minded as some of the really smart experts who are stuck in the weeds and don't have a general enough perspective,
Yo, hit me up when you figure out the Earth is flat.
There you have it. There you have it, guys.
I do what I can, But thank you, sir. There's still so much learning to be done. So much.
Of course. I know that also.
And praise be to God for reforming my mind every day and making me wiser,
Hallelujah.
Allahu Akbar.
Yes, that dude God, he's reforming my mind even currently. I pray to him and I'm like, Lord, give me wisdom. Show me your ways. Show me the truth. And sometimes I, get a revelation.
Lemmerberg, should I thank God for that? Or
Glory
should
be
I
to
thank
God.
you for that?
Should
I thank God for it, or should I thank you for that?
Like all things,
otherwise I would puff myself up and become vain and, big-headed. Praise be to God.
Like all things, God created the LIGO vacuum tube as well.
Well, God appears to have made this place flat, like clay pressed under the signet ring.
Okay, that's pretty fucking funny.
It's so wonderful. It's not funny. It's wonderful.
No, it's fucking hilarious.
Oh, really?
The truth can be funny.
The Hillarys and everything is funny, of course. The life can be funny. There's nothing wrong with that.
What are you saying there?
There's nothing wrong with that.
And there's nothing funny with my measurements because God created my instrument as well. And God gave me the intellect to use the instrument. And then Lemon says, oh, it's not anything what I think it is because Lemon's smarter than MIT and the Ordnance Survey UK and every fucking university.
Why
Lemon's
not?
like,
Why not? Why not?
But hold on. Lemon is a genius, man. He knows everything, right?
Dude, I saw that video.
100 IQ, but the thing is, you did your experiments very nicely, sir, but the interpretation may be need a little bit of work. Namely, you need to have a level line to determine if anything's going above or below that level line for a ball. And I think that you don't have a level line because your level line is disappearing due to perspective and the diffraction limit. So after a while, your instrument's useless, especially close to the surface where everything's merging so much you can't really tell what's going on.
Wait a minute. What's wrong? What's wrong with the 40x magnification with an f2 aperture at 12 miles. I mean, fuck, P900s do that all the time. I could see great detail at the far. So nothing has gone past any diffraction limit. And even without the telescope, I could still see the outline of the tower quite fine, just with my own eyes on a good clear day. So nothing disappeared. And it was below my local horizontal, which I made very, very carefully off the vertical, the plumb bob, just like everybody else's auto level, like Bev uses, or everybody and their brother uses an auto level. I get the same horizontal that they do, the same way they do.
Your horizontal will suffer from things merging into the surface, so you can't just eyeball it. You have to check your assumption with something that travels straight and true with little to no deviation and much power, like a laser. If you shoot a laser over that distance and it hits the target, no hump of Earth curvature in the way, then your eyes may be deceiving you as the sky merges into the ground and converges into an unresolvable horizon line in the middle, where you can't tell what's up, what's down, or what's above anything else.
Hey, Lemonbird, do lasers go straight?
No, and to address those issues, I was going to address those issues. I was ridge to ridge across the valley where the line of sight never got anywhere near the valley floor. And the far tower was clearly below my horizontal, as established the same way everybody establishes their horizontal, by the vertical, from the plumb bob, by the auto level. And I measured the angle down, and the angle down was just a scant little tiny 1 arc minute. Yeah, unfortunately, that tower is also 400 feet higher, but it ended up below my eye level. So no, I didn't eyeball anything. I used tools.
What are you talking about?
The tools are good enough, but the thing is, you start with your theodolite, your instrument telescope, and you try to make it as straight as possible. But is it going to be perfectly straight? It may be off by a fraction. It may be off by a hair, and eventually it'll just point off into nowhere. Need a physical operation with a laser to verify that you're actually at level. That's where the laser comes in. It gives you a straight level with a physical operation by traveling with little to no deviation over a long distance and hits the target. So you still need to check with the laser because you're eyeballing it when things converge, merge, and disappear due to perspective and merge with the surface, making your level line, garbage at that point.
Lasers are useless because they refract.
And lasers go as straight as possible. They're the straightest standard that we have, and they don't appear to go 8 inches per mile squared, so that's good enough.
Then
everybody has to understand what Lemonbird is talking about. If you don't understand it, you can just say, because you're talking, I don't understand.
Go back
Therefore, Lemonbird talking shit, because you don't understand it.
We can do this.
If you're really listening to it, you might maybe understand something of it.
Open up your mind. There's truth inside. Flat truth.
No, round truth, but lasers refract, so we can't even use them to measure for...
They don't refract at 8 inches per mile squared, and refraction happens at the boundary between media. So unless you can show a big temperature difference in a big, refractive medium of some sort with boundaries between them, I think that's somewhat irrelevant.
I don't have to show a big temperature difference. All I have to show is a 1 degree, 2 degree temperature difference and any modicum of humidity difference over the course of several miles to give us just a few inches.
This is where the question of philosophy comes in, because people treat the air as one more or less homogeneous medium as long as it's of a similar enough temperature and there's no great variations between layers. But they try to invoke refraction where you're going from air to water, like looking at a straw, which has great enough differences between the media to show a discontinuity and reflection between the surfaces, yet that's not what we see when they invoke refraction. So I think they're kind of begging the question unless they could show a marked discontinuity, number one, and number two, reflection or some sort of barrier where the light is bouncing off of to be quite indicative of refraction, like with a straw. So I'm going to have to challenge their premise.
Thank you, Lambert. Can I say before I know the answer? Can I say we have to know the limited of our understanding? We have to take that we understand and not take all thing in the big thing. We have to take the in a small step in a step for step.
Right. Some people understand more than others.
Maybe Lemmy could show us his test data where he's verified his assertions.
Yeah. We're at the theoretical experimental stage yet. This is just to guide future experimentation in the hopes that there would be some verification of this theory. We're at the theoretical level currently.
So, question about this theory, Lemon.
In 2019, they repeated the Mount Everest survey with vertical angles and GPS and still got the same answer they did in 1860.
Well, GPS would be a computer software program by, some glow geek with his own glow bias. We need to see if it matches reality yet again with a laser. We need to see if we can hit the bottom of that mountain through the hump of said Earth curvature or not.
You're going to have to test your assertion there, Lemon. Theoretical. I went practical, and you're still stuck in theoretical. So get out there, man. You got some legwork to do because let me tell you, it's been tested.
Well, on the other side, we have competent, practical people like yourself with very questionable optical theory and interpretations. Because of that, so on the
you're questioning the Academy of Sciences Paris. Is that what you're asserting, that you're smarter than the Academy of Sciences Paris?
Maybe a little bit less biased.
All the people are more.
I do submit to foundational truth, and I don't let my atheism, materialism, and heliocentrism color my interpretation of obvious flatness by saying, it went behind a hump of Earth curve, as opposed to, maybe parts of the end got eaten up with the fragments by me being too dang close to the flat ground.
Right,
so I think I have a different perspective that may need to be, examined here over a flat plane.
Okay, let's let K-Bose get his question. I think he's been trying to ask a question.
I had a specific question for you, Lemon. Why do you theorize that the laser has to drop 8 inches per mile squared? Where does that come from? Could you clarify at all why you keep on reiterating that?
Well, you need to establish the rate at which it curves, and if it curves less than the supposed curvature of the Earth, it would still give a straight standard, a straight Earth standard, by which to measure the curvature of the Earth. The essential thing is seeing if you had a straight standard to measure the curvature of the Earth against. If you don't have that, no curvature.
We don't have a straight standard, unless you want to go out and build a 5-mile long straight ruler that doesn't warp.
And you can use
lasers in microwaves that are very...
Lemon, you don't have
waves that are the creme of the creme. They're straight enough. And we also have water, which we know is flat and level. What was that?
You don't have an ice ring.
We have Antarctica, which is 60,000 plus miles.
An island continent.
Miles, where do you pull that from?
The voyages of Captain Cook and others.
So when you
see, Lemon, none of that makes sense. Because you try to stipulate that it should fall at 8 inches per mile squared, but you would want it to be straight as in difference so that you could show that there is an 8 inches per mile squared drop. Does that make sense to you?
Well, you still have a straighter standard with lasers which don't curve at 8 inches per mile squared. That's absurd.
Right, it's absurd to try and stipulate that they should curve at 8 inches per mile squared.
Light does not, except maybe when you get really, really close to the ground, like what Robotham so nefariously did, have only be followed by Wallace getting only 15 feet above the water and got the curve that everybody sees today.
Yeah, so you can take a look at Captain Cook's journal and you can stop misinterpreting it, stop misquoting it, because 60,000 miles is his entire journey from England down around the continents, around Africa, and then back up to England again.
There's another dude who clocked 70.
Yes, 70,000 miles from his starting point to his ending point.
Over like a three year journey.
Yes. 60,000 kilometers in the 3 months that it took him to sail around Antarctica. That'd be 27 miles an hour for a fucking sailboat back in the 1800s. That'd be fucking nutty ass speeds.
Well, Robotham and them are clocking way too much land toward the south. And Robotham's accounts say that the sun appears to be traveling faster to the south based off of dusk appearing to arrive sooner in the south than the north based off of the travels of the person he was interviewing or whatever. So it looks like the sun is going the same 24 hours, but a little faster as if it's going over. So all of these things appear to be pointing to more land toward the south.
I think that you're just grossly misinterpreting his comparison between the north and the southern hemisphere and the days at the time the sun is in the sky at the exact same day it would be in the north, which is what you would expect if he travels from the north during their summer. It would be winter in the south, thus shorter days than in the north.
Lemon just hates reality, and he hates human accomplishment. That's all he has.
That's not quite. I think we just need to check the humanism that makes us, a little arrogant, and think that we can, number the crap out of reality with our Pythagorean cultism, trying to make the Earth into a globe that can easily be mapped out of with, spherical geometry and stuff. I think that's man's conceit that they can do that when that's not necessary.
I don't think Lemon hates reality. Lemon hates reality if it doesn't agree with them.
Lemon hates reality if it makes him feel unimportant. I think that's.
It measures flat.
It doesn't measure flat though, Lemon.
Yeah, we have survey gear that says otherwise. We have
I measured it a couple months ago. It's not flat.
So, what do you guys get out of pretending that it's a globe?
What do you get out of denying that it's not globe?
I mean, Jeranism measured that it was a globe, didn't they?
Yep.
Interesting. Oh, you're talking about that light.
What's the shape? What's the shape of the water in the Amsterdams of the canals of Amsterdam?
How can you say a shape? Water doesn't work that way. You can't say it can be a shape or not be a shape.
You'd have to that would be curved.
You want proof of curvy water?
What's
you guys
the
want
shape
proof
of
the
the
water
canal?
curves?
Fluid. You can't say whether water curves or doesn't curve. It's a fluid. It doesn't act that way. You can't say you can't put it into a shape. It just
You can kind of logically deduce that it would be flat on top because of the mechanism of flow. Flow is one part of the liquid going above or under another. So when the liquid stops flowing, one would assume that they're all on the same level and there's no part where the fluid can go above or below another one to flow. That would lead one to...
You're talking about density, Lemon. You're talking about density.
On the top, don't you think?
You're talking about density of fluids, Lemon. That's got nothing to do with it. It's still not a shape.
So the mechanism of flow, one would logically
Amsterdam, Merle?
flat on the top.
Amsterdam is real. Canals are real. They have shape.
If you haven't been to Amsterdam, then it doesn't exist.
So there you go.
Yeah, how do you know Amsterdam
It's all
exists?
based
Well,
on
what does that prove? Amsterdam's real, and so what?
What shape would you say the canals of Amsterdam are?
Well, that's got nothing to do with the shape of the water, like
this is not following the logic to a logical conclusion. Just state the conclusion. He's just going to obfuscate and frustrate the shit out of you. Just state your final conclusion.
What shape are the canals? You want proof the water curves? Hold on a second. I got proof the water curves. Hold on a second.
Yeah, so actually.
Okay, hold on.
Water conforms to whatever forces act upon it.
So what's your excuse of when it's in
Here
the
we go.
canal?
Water curving. Here you go.
Yeah, water's curving.
Right there.
Yeah, canals are curving.
Curving water. Next.
No, they're not.
So what shape are the canals?
Merle,
So
have you
why
ever
are
heard of
lying
the
about canals curving?
Merle? Have you ever heard of the David Taylor Memorial Model Basin?
No.
So this is a really cool ship testing facility in Bethesda, Maryland, United States, owned by the U.S. Navy, operated and tracked every about 3 to 6 months, depending if we're on a war or peace footing. There is 2 metal beams that have a deviation of 9 inches from one end to the other. However, at every place along that metal bar, there is they are exactly 18 inches above the surface of the water. It is completely level, but not straight.
Where is this again?
Bethesda, Maryland. Just put
and you said
more bending water. Interesting.
You said the name of this bridge or whatever the heck you're talking about is what again?
Of course, they're going to ignore that though.
It is the David Taylor Memorial Model Basin. I just put the link in chat.
Thank you so much.
And if you really want laser tests, I have laser tests going back. I believe I've seen them up to 20 years, but they've been measuring it for quite a while. That shows that it's all level. Not flat, but it's level.
So how much expected curvature should we be seeing over this half-mile pool?
Did you hear what I said?
About 2 or 3
said
inches.
it's about 18 inches. Is that the expected curvature?
No. The rails that the gantry cranes sit on are 18 inches above the water.
So you're saying we'd expect 8 inches of curvature over half a mile?
There's actually 9 inches on that.
That's a little much.
Yeah,
it's actually 8 inches per mile squared.
No, but it's not, because that's a parabola.
That's what you expect when you work out the formula, r times 1 minus the cosine of however far you go along the Earth's surface, times 360 divided by the circumference of the Earth. It works out to 8 inches per 0.0001 miles, which works out to 8 inches.
I'm not
so you have
good
way
at
too
math,
much
but
curvature there.
8 inches per mile squared, if you graph it, is a parabola.
As it necessarily has to be, because the equation of a circle
It just is. Stop denying reality. It just is. Jesus Christ.
So the equation already has x squared, so that's irrelevant because it will already be in the equation. You do know that it's x squared, right? Therefore, it would be 8 inches your rate per x squared or per mile squared, so that's irrelevant.
Is this over a river or something?
8 inches per mile squared is a hyperbola, not a sphere.
What is it over?
Because the equation for a circle has x squared already in it, as I said. So that's irrelevant.
This is a man-made water basin where they test ship design.
Where they test what?
I've just posted the picture in the chat. Have a look.
Okay, I'm asking what body of water it's over.
It's a man-made model basin. They test ship design.
It's half a mile, so that would be like what, 4 inches or something like that. You'd have to solve for R3
not a
times
linear measurement.
Rates to the Earth times 1 minus the cosine of going half a mile over the Earth times 360 divided by the circumference of 24901. So that would be about what, 4 inches expected as opposed to 8 or 9. It's probably some sort of.
No, that's not a linear actual relationship. If you're doing the actual 8 inches per mile squared, that would be half a mile, which would be 1/4. So you're looking at like 2 inches.
That's what I said, 2 or 3 inches.
Way too much curvature then. So I'd say that that's a construction consideration, not the curvature of the Earth based off of that anyway.
No, you are actually 100% correct. They had to come up with brand new milling and pouring techniques in order to get those metal rails to be level, not straight, level.
Yep.
For me, I digit or two, like maybe 7. I'm sorry, you said it was 2 inches, so maybe like, I don't know, 1 to 4. That would be the limit for me conceptually, if that. But if you're saying it's like 8 or 9 inches, too much for me.
Why is that the limit for you conceptually? Does your brain not expand that far?
I need to see this converge around the value. Arbitrary.
Cool, I sent you the link.
8 inches per mile squared is a drop lemon. It's not the sagittal.
So it would be the drop from the initial position. And the sagittal in the middle would be 1/4 of that value.
That's right. It's the sagittal that's the issue here, not the drop.
So you're saying that the hump in the middle is 8 inches? That's still way too much.
No one's saying any of that, Lemon.
Then what are you saying? I have to draw conclusions off of what you're saying based off of this argument. So what argument are you trying to make? Because if you're not making a conclusion, then I have to derive a conclusion from whatever evidence you're offering. So what are you trying to say?
Okay, here's what I'm trying to say. There is metal rails. They are exactly 18 inches above the surface of the water at every point on those rails. Those rails are not flat.
Therefore, you're saying that we're on a globe?
No, therefore. Those rails.
Okay, well, if you're not making an argument, there's no therefore. Therefore, I'm going to have to derive my own conclusion. And my conclusion is not a sagita of a fourth of half a mile of 8 inches per mile squared, whatever it is, no ball based off of the pure calculations. That is my conclusion and my argument.
What your argument then is a straw man of the actual proposition and point, and as such will be disregarded.
We're talking about the shape of the Earth. So the only conclusions I can draw based off of the argument that we're currently having, supposedly, is that. Now, if you're not willing to make a point other than that it's 18 inches higher than it should be or whatever, then what you're saying is ultimately irrelevant because you're not really making an argument. You're just putting out evidence and letting it sit there without arguing it, without reasoning it, or helping the person come to a conclusion. So I'm going to draw my own conclusion and say, if it is not a fourth of half of a mile of 8 inches per mile squared within certain ranges and bounds, say like a digit or two, whatever, irrelevant.
Okay.
What's your counter argument?
You want a conclusion? Level is not flat. Level is a curved line.
Yeah, you're retarded. Well done.
Why is that retarded? I literally am showing you a curved line that is level.
Listen, I don't want to embarrass you, but we've got a 90-mile long guideway system here that's built within 1 millimeter tolerance through its entire length. If you guys want to punk with the engineering department, go ahead.
Yeah, it's level. So what?
Right. Level is a curved line, as shown by the model.
Even in that article you sent, it says the rails on the basin walls upon which these carriages will run had to be far straighter and more level than the most perfect railway track. So which is it? Is it curved or straight or level?
It is
curved. Do you guys even know what you're talking about?
It's curved and level.
Yeah.
Level and curved. It's straight. Did I just hear that again, Mo? What was it? Straight? Then say that bit again. Don't mind.
The rails on the basin walls upon which these carriages will run had to be far straighter and more level than the most perfect railroad track.
Do you think that can be interpreted as left to right straight, or in your mind is it up and down straight?
No, it's tolerances on railroad tracks are not that straight.
Yeah, so what I'm saying is straight-wise, right? Left to right, right? Because again, when you're running a rail, even around a ball, you want it to be straight in comparison to left and right. You don't want it to have to be fucking wiggling left and right. So again, it's just your lack of comprehension, which I don't know how to get around. Yeah.
There's one person with common sense, and he hears the space of the fog your bullshit that you try to hide behind by saying that you're a smart boy and that you believe the establishment bullshit. Peering through the veil of
you missed the first bit.
Lemon, I came in because you were wanting. Hey, no, it doesn't, Mo. But
I just read it. It's straighter than a train track.
Okay, so I came in.
And railroad tracks are laid flat, so by logical extension, it's flat as well.
Tell you what, when you guys are ready for a conversation, I'll come back.
I'm ready for a conversation when you stop bullshitting and obfuscating.
After
5 years, I don't have time for that anymore.
No one's bullshitting nor obfuscating.
You're trying to hide behind the veil of gobbledygook and being a smart boy and pushing the establishment rhetoric without really absorbing it or analyzing it on any real level. That's full of shit.
The only gobbledygook going on here is the shit between your ears, Lemon, that cannot take back.
It's greater than railroad tracks which are laid straight, then it's flat, logically.
Left to right.
Left to right. Left to right straight. You don't
Level
want your
is up and down, straight is left to right.
Yes.
Probably 18 inches high because of the waves too. the waves crest and get pretty high. So it probably needs to be 18 inches high to account for those waves too.
What's causing the waves in this underground pool?
They use a mnemonic processor, according to your article, to blow and cause the waves to
Not
form.
Not in the memorial model basin.
That's them blowing the air to get waves. I need to see how high the waves are too.
You're looking at the wrong model basin.
Yeah, you see like little ripples.
Yeah.
18 inches, that's like fucking, that's bigger than lake waves.
It's 18 inches, foot and a half. Lake waves? Well, oceans are much bigger than that. So you're saying waves are only a certain height? How big do lake waves get?
6 inches.
Okay. They probably made those rails for the waves then. That's what I would say with my religious-tarded, flat-tarded self.
I don't think there's enough water to make like 18-inch waves just by standing.
But the main logic breaker for me is if it's straighter than railroad tracks, it's flat, because railroad tracks are laid flat on flat datum.
It says it's straight and level. And we
what about
know
railroad
that
tracks up a mountain? Those aren't flat.
We know that the
don't they build it straight through the mountain though?
The rails are bent. Like you're arguing that the rail isn't bent, and we know
they build it around or through the mountain, so they still keep it at the same level.
It depends on the mountain. Sometimes they have to go around or up the mountain. Sometimes they go through the mountain.
Pikes Peak has a railroad up the mountain. You actually go up the side of the mountain to the top.
Yep. Therefore, it's not level, but the railroad lines are laid straight in comparison to each other. Can't have wobbly trains.
I mean, there's actually a grade to the railroad tracks. There's a grade to them.
You can also build to accuracy, though. There are, there's guideway systems that are built to a 1 millimeter tolerance.
Yeah.
Engineers are what's going to kick this subject off its hinge.
Then why are you? Then why are you ignoring?
Engineers come in, you guys are fucked.
Why are you ignoring
the scientists or the physicists anymore once the engineers come in?
Why are you ignoring the accomplishments by these said engineers in building this model base?
Only for the purposes of the flat or round discussion. These are capable, smart men who have been deluded and led astray by the.
Then why is the bent gantry crane rail level?
As I said before, waves. Hopefully you processed my answer. Waves.
No, I'm sorry, that doesn't make sense to me.
They would make it higher for the waves, which can crest at least to whatever Squatting Dog was trying to imply, 6 inches based off of a lake.
I don't care really.
How about I smack you all the way across the flat earth?
The waves aren't the important point. The 18 inches above the surface
of the water. They need to make the
guardrails
higher than that, right?
They're guide rails, not guardrails. And the guide rails are 18
rails that are
inches
above the waves. Otherwise, if they're too low, the wave will push up the boat past the guardrail and potentially break it. That's what I
Lemon. You are completely making up what this model base is, sir.
And you're not processing what I'm saying.
Because it doesn't make sense. Listen to the way the model basin works and then debunk that rather than making up something else.
Make an argument relative to the shape of the earth and maybe I can listen to you. You're putting out evidence, but you're not interpreting it. You're not arguing for it, and you're not showing how it shows one thing one way or another. And I'm countering that they made it 18 inches above, probably to go past the waves. And I feel like that's a very valid option.
What waves?
The waves that they generate to push the boats through there.
No, that's not the way they push the boat. The boats run on a gantry crane. The gantry crane is what is actually doing the moving. It used to be run on steam power. It is now run electronically because the engineering has gotten better. That's what is running on the rail. it needs to maintain a specific height above the water so that the boat, when attached to the gantry crane, rests correctly in the water, and they can push it along. They test model ships in.
Engineers don't lie.
So you have way too much curvature, number one. That's a big non-selling point for me. Number two, the waves could explain this with my religious-tarded bias, flat-tarded self. So for me, this is negative. And number three, the final breaking is it had to be straighter than a train, which we know are made out in flat datum. So I'm sorry,
This is futile at this point.
Train tracks aren't made level. They go up and
irrelevant.
down.
Irrelevant.
What do you mean irrelevant? You're trying to use it as a standard. Fucking. And so when they say straight, they're referring to left and right. Like
For the purposes of the argument, Chief Squatting Dog, so that you don't waste time, you need to show that they account for 8 inches per mile squared of curvature. That appears to not be the case, saying focus on the argument. And at best, they try to build around mountains, through mountains, around them, or whatever, as needed as an eventuality. So what you're saying, get into the
There's no mountain in the model pool.
The relevant part of the argument, Chief Squatting Dog, Chief Squatting Obfuscator, is whether or not there are 8 inches per mile squared that needs to be accounted for past the flat datum, and that does not appear to be the case. Irrelevant.
You're literally saying that this rail we know is bent isn't bent.
No, you're saying straight lines are curved.
No, again, you're saying that you're trying to, again, when they have to say straight, you're trying to mean that that's up and down. That's not what they mean. They mean left and right. It's like a straight road, straight ahead, right?
Vertical is plumb bob. Horizontal is spirit level using water.
Right. And this is level. However, it is not straight. It is not flat. Okay, it's straight. It's not flat. Is that a better vernacular for you?
Yeah, well, straight is just that. You know?
Hey, is this train line. Is this train right here level? Is the train level? Or the train tracks, I should say, level? I'd say no. Is it straight? I would also say no.
I'd agree with you.
Is this train level, more or less?
Yeah, more or less.
Is it straight?
No, it's not straight.
I'm glad we can come to that fucking agreement. So when they say straight and level, I'm glad that they're making the distinction between the two so that we could do this. So we can have this conversation.
We weren't in the confusion though.
I think you are, because you're trying to mean that it's talking about the same thing, up and down, level and straight. When they say straight, they mean left or right. Is it that hard to understand? Do I have to explain it to you again?
No, you didn't explain it to me the first time. I already understood it without your help or assistance. Thanks though.
Okay. So what are you
Globe
trying to argue
Earth, Globe Earth tried to adjust the term of what level meant. That was the globe. That was your sneaky team side, not us.
Yeah,
no, that's actually incorrect. We accurately described what was observed. You are the ones that try to shift it and malign it like you just did, of all these different things meaning the same.
You got us fucked up.
Yeah.
So.
Yeah, I think we are fucked.